This next graphic is entitled Unsaturated Flow by Capillarity. So we're talking about the flow or movement of water in the soil due to the retention by the soil pores, and we're talking about unsaturated flow, meaning that we are not moving under, such as water being applied at the soil surface as it infiltrates. That's saturated flow. We're talking about water moving from one set of pores to another in the soil profile at less than the saturation point. The first part of this diagram is explaining capillarity, the process of capillarity. Now this is a chemical concept, and it's talking about the height of rise from a free water surface, free water being that which is not held by the soil, but it's free to move, and it's explaining it on the basis of the diameter of the tubing. The smaller the diameter of the tubing, the greater the height of rise of water from a free water surface. So in this extremely small capillary tubing or glass tubing, the height of rise would be quite high. As the size of the tubing gets larger, the height of rise from the free water surface gets correspondingly less, to where at some point in time, if we have extremely large diameter tubing, that height of rise is going to be pretty insignificant. Well, soil pores act very similar to capillary tubing. That is that the height of rise of water from a free water surface, the groundwater table, upward in the soil will be far less as we have larger size pore spaces that correspond with coarse sandy soils than that will be in a soil that has smaller size particles. Here in this particular illustration, we're comparing a coarse sand to a fine sand. And you can see from the illustration at least that the height of rise here is more than twice as far. Well, if we were to go over here and put a third or a fourth column on this particular graphic and say that let's look at a silt soil versus one high in clay, the height of rise would be even greater in the soil predominated by silt-sized particles and even higher yet in the soil that was predominated by clay-sized particles. The reason for that is that smaller soil pores have the ability to retain water at even a lower content. Or another way to look at it is they have the ability to transmit water at a lower water content than do the larger size pores, which are more typical of larger or coarser types of soil textural classes. Capillary rise of water, the rise of water from a free water surface below the soil upward in the profile, is a process that is fairly significant in soils throughout the growing season. As we see water utilized from that segment of the soil profile where the roots are most actively absorbing water and nutrients, we will get some capillary rise from areas, or capillary movement, I should say, of water from areas of higher to areas of lower moisture content. Now, capillarity is not the only force acting in this movement of water under unsaturated conditions, but is one of the primary forces. A concept that we will be introducing soon in this unit is the concept of soil water potential. And there we'll be looking at the movement of water due to a number of forces, not just the matrix potential or the pull of the soil particles for that soil water from areas of areas of higher water content to areas of lower water content in the soil profile. Also illustrated on this particular diagram is capillary rise in different textural classes of soils. So we're looking at the capillary rise of water in centimeters over a period of time in days. So if this represented a free water surface down here below this level, and we looked at the movement, capillary rise of up in a sand soil, a very coarse textured soil, what amount of water was going to move would move quite quickly, but then it would be able to move no further, so we would level off, and they're saying here in this particular situation, it might pull it up to a depth or to a height of approximately 20 centimeters. If that were a loamy sand, one that is still a coarse textured soil, but now this inclination of loamy is implying that we also have a more substantial amount of silt and or clay-sized particles in this particular soil texture, it will take it a longer period of time to reach its full potential, But somewhere out here around day 5 or 6, that loamy sand soil will have pulled water up to as high as it can possibly go based on capillary forces alone. And that might occur to a height of somewhere around approximately 40 to 50 centimeters from that free water surface. And then if we were to go to the other end of the chart and go into a very fine textured soil, a clay loam, it does take a much longer time for capillary to get that water up to its eventual height in the soil profile. Somewhere out here, even past day 10, we may still be seeing capillary rise of water from that free water surface upward in that profile until it actually reaches an equilibrium point. So from this diagram, we should be able to obtain a couple of points. One of those points being that coarse soils do have capillary rise, but it occurs very quickly and reaches that equilibrium point very quickly. As we increase the loaminess of texture, meaning the silt and or clay component of the soil, we do not see as rapid of a capillary rise of water, but we see a much more continuous and complete capillary rise over a longer period of time. From this particular illustration, I would expect you to be able to understand and explain the concept of capillarity, how soil pores act similar to capillary tubing, and why smaller pores have the ability to pull water up to a greater extent than do larger pores or larger sized soil particles, given the other variables in the situation here would be somewhat constant. Well, soil pores act very similar to capillary tubing. That is to say, if the water content of a soil is high, both the large pores and the small pores will have a substantial amount of water in their total volume. However, as that soil begins to lose water, what we see is a rapid emptying of the large pore spaces and a much slower emptying of the smaller pore spaces between the smaller sized soil particles. The small pores in the soil will retain water at a much higher tension, whereas the larger pore spaces only retain water when the soil water content is quite high, which is to say that the amount of tension with which the water in the soil is being held is very low.